Hello, and welcome to the first lesson in our long journey into the study of Algebra 2 Honors. We're going to start off this lesson going back in time a few years to when you first learned about our number system and all the different subsets of numbers that we had. As you can see, we have the real number system is the main number system that we remember, and actually later on in this lesson you're going to learn that our number system actually grew. And we have more numbers that we have to add to this. But for right now, we're just going to deal with what we've dealt with before, and that's the real numbers. I have two diagrams up here, one a Venn diagram, that's the one with the circles, and one a flow chart. In there, you'll see all the different subsets of numbers. You'll notice that in the real number system, we have two big sets called rational numbers and irrational number. The root word in rational and irrational is the word ratio. And a ratio means that you can write the number as a fraction. So a rational number can be written as a fraction, where an irrational number cannot be written as a fraction. Most of you should remember that irrational numbers are non-repeating decimals that don't end. For example, pi, or the square root of 7, and there's several other ones that we'll get to throughout the year. So that's in a set all by itself. Inside rational numbers, we have several subsets that get progressively smaller as we go down. Integers are your negative and positive numbers along with 0. So like -6, -5, -4, so on and so forth. From negative infinity all the way to positive infinity. No decimals, no fractions, so those are integers. Whole numbers is a smaller set of integers that actually starts at 0 and goes to positive infinity. So a negative number would not be considered a whole number. And the last and the most restrictive of these sets is natural numbers. And that actually starts at 1 and goes to infinity. No decimals, no fractions. They're also called counting numbers. So if I asked you to count to 10, where would you start? You'd usually start at 1. The way you can remember if something is a whole number, or where whole numbers start, is a whole looks like 0, so you'd start at 0. Natural numbers, well, the very last letter in natural is an L, and an L looks like a 1, so you start at 1. And that's how I remember them, and hopefully that will help you guys. Next, let's talk about some of the properties that we'll deal with in real numbers. At the top here, we have the properties of real numbers: commutative, associative, distributive, identity, and inverse. Obviously, you can read them. 3 of those we don't really care too much about, at least I don't personally, but there's 2 of them that are very important, and you should know what they are: distributive property and inverse property. Distributive property is what we use to really get rid of parentheses. It's a multiplication over addition or multiplication over subtraction. So inside the parentheses, you'll have 2 or more terms separated with plus signs and minus signs. And on the outside of the parenthesis, you'll have usually a number or a variable that we could distribute in through multiplication. The inverse property we use all the time in solving. You probably don't even realize that you're using the inverse property, but you're doing it all the time when we're solving an equation. Down here at the bottom, we have properties of equality, and you can look through those. Some of those should look very familiar. The only one I really care about is this guy down here, and that's substitution. Substitution is when you take out usually a variable and replace it with what that variable is equal to, so we can either solve or simplify an expression or equality even further. So there's our properties. I really want you to know those 3 properties: distributive, inverse, and substitution. The other ones, I guess it's fun to know, or not so fun to know, but those 3 are for sure important. As you've moved through the years of your math career, you've probably seen these words over and over again on your homeworks. The 3 verbs are evaluate, simplify, and solve. If I ask you to evaluate something, I'm going to give you an expression that has at least one variable, maybe several variables. I'm going to tell you what those variables are equal to, and I'm expecting you to substitute that value back in for that variable and then to simplify the expression. It should come down to a single number, or sometime maybe later on in this class, it may come down to something that has more variables, but that's evaluate. Let's move on to simplify. Simplify has a lot of stuff going on. So right now, we're just going to deal with a little part of simplifying, which is getting rid of parentheses through distribution and then combining like terms. At the end, you should only have one of each type of term and no parentheses, and that is what we consider simplified. The last one, and probably the one that we've seen the most often, is solve. To solve, we have to have an equal sign. And usually, I'm going to tell you what to solve for. I might say solve for x, solve for y. Heck, I could say solve for 7, and you have to be able to solve for 7. Many times in solving, when you deal with the left side or the right side, you're going to have to simplify first before you can get to the solving portion. So it's really important to be able to simplify, because if you can't simplify, you won't be able to solve. And these are the 3 main verbs that you'll see in most of your math homework questions.